The last part to this video, I'm going to talk about even and odd functions. So even and odd functions. So just a quick reminder, an even function, it has reflectional symmetry about the y-axis. Odd function has rotational symmetry about the origin. Okay, so that's the important thing to remember about even and odd functions. So if I were to take a look at, let's say, an even function would look something like this. Y equals, let's say, 3x. So this would be considered to be an odd function because if I end up taking the right-hand side of the graph, right, if I end up looking at this, at the origin, right, if I rotate it, in a sense, 180 degrees, I would end up back in that same location. Another type of problem like this, we could also say that x to, let's say, the third. That also has rotational symmetry. Now, something that is even, right, y is equal to x squared, right, so this has reflectional symmetry about the y-axis, means that if you fold it on top of itself, right, if I end up having some type of graph, right, my good old parabola, if I reflect it over the y-axis, it ends up folding on top of itself, and so therefore that is considered to be an even function. Now we're going to talk about these in terms of integration. So I'm going to erase these just a second. So the following, so these are important, so these are theorems. And some of you guys could probably think about how these are actually organized before you even start this. But if let's say, if f is an even function, so think about that parabola, then if I said the integral from negative a to a of f of x dx, what would that be equal to? So if I were to say, let's say that this is negative a, this is a. I'm going to draw that parabola. So what can you tell me about the area from negative a to a? Well, since it has that reflectional symmetry about the y-axis, I can actually rewrite this as 2 times the integral from 0 to a of f of x dx. Now we could say if f is an odd function, then the integral from negative a to a of f of x is equal to, all right, so think about that linear equation, right? If I came along right here, let's say that this is negative a, this is a. What ends up happening here is, right, this is my shaded region over here, this is my shaded region over here. What happens with both of those areas, right? Because there is that rotational symmetry, which means that those areas are going to be exactly the same, right? Remember, when it's below the x-axis and bounded within the actual function itself, that's actually going to give us a negative area here, but a positive area here, and what's going to happen most likely, it's going to cancel, so it's actually just going to give you the value 0.